Hey, so welcome to Well-Architected, the Backstage Tour. I'm so glad you folks could all join us here today. I have your Backstage pass right here, and I'm really hoping you're going to enjoy it. This is the event that I've been waiting for a long time, because we know that people care about reliability, security, cost optimization. They care about performance, efficiency, and operational excellence. And we're going to bring that all here to you today. But we're going to do it in a way we've never done before here at Microsoft. Is we're going to take you behind the scenes at Azure, so you can see how we power the stuff we use to help with all this stuff. So I'd like to get us right into this sort of thing. So let's get started. Before we do, I want to do a few housekeeping notes just so everybody knows what's going on, and we have that. The first I want to mention is we have a code of conduct for this event and all of our other events. It's here on the screen. It's also on the event page. We ask you to please respect it. It's really important to us, and we take it very seriously. So the next thing I want to tell you about is our upcoming agenda. So here's what we're going to be doing. You're in the middle of the welcome now, and we're so glad that you're joining us here. We're going to have a keynote and a welcome from Mark Russinovich, followed by 5 excellent sessions. And for each session, we'll have 15 minutes of a session, followed by 5 minutes of live Q&A with the experts. But I also encourage you to make sure that you go to LearnTV and that you join us in the chat and you ask your questions, because we'll bring those questions right to the experts, both right after each session, and will be available for a little bit afterwards, during other sessions. So I want to welcome you to this sort of stuff, and I think we should just get started. So the good news is we thought the right thing to do, if we're going to go behind the scenes at Azure, is to have you be welcomed by the Azure CTO and technical fellow himself, Mark Russinovich. So here's Mark.
Hi, I'd like to welcome you to Well-Architected, the Backstage Tour, and thanks for joining us. This is my kind of event, and I think you're going to love it too. We get to talk about topics I'm really passionate about: reliability, security, cost optimization, operational excellence, and performance efficiency. All these areas are critical for workloads to be successful on Azure, and it's Azure's goal to make it as easy as possible for you to be successful. What's great about this event is that we'll show you some of the hard work we do here in engineering behind the scenes. And with that tour, we're going to include a lot of insider tips on how you can leverage that work to run your cloud workloads so that they thrive on Azure. To keep in the spirit of this event, I thought I'd share some of my own behind the scenes looks at Azure. Every year I give Inside Azure Data Center session, the most recent one at Ignite in the spring. And here's a little clip that shows you behind the scenes of Azure's data centers.
Another great place that we're applying Resource Central is in minimizing customer impact towards failures that we think are imminent. And failures that are imminent would include ones where we're getting signals from the hardware in our servers that it's starting to produce errors. Those errors might be correctable at this point, or there might be a failure of a component. That component is not impacting any virtual machines, but signals that that server is going to be moving likely into a degraded state. And we're using Resource Central to take those signals, create these models of how a server is going to perform. How likely is it going to fail? What's the timeline before it fails? And then also figuring out the best ways to respond to that. In some cases, it just means resetting the server. It could be a software-induced failure, and we might need to do what's called a kernel soft reboot, which means just resetting the hypervisor environment, but leaving the virtual machines preserved in place through that process. And Resource Central, and through Project Naira, has been operating now for about a year in production. And as a result of it applying this kind of intelligence to prediction and the best way to mitigate the impact, we've seen a 26% decrease in VM interruptions, meaning some software or hardware problem on the server is causing an impact to virtual machines. So already huge impact, and we're just getting started with this kind of capability.
So coming back to the Azure Well-Architected Framework, which is our set of guidance and best practices for workloads, it has exactly the pillars I mentioned earlier: reliability, security, cost optimization, operational excellence, and performance efficiency. And like the behind the scenes you just saw, where we're building things to satisfy multiple different, often competing needs, the Well-Architected Framework also recognizes that nobody has the luxury to pay attention to just a single pillar. The WAF is there not only to show you how to help build good stuff from start by asking the right questions, but it also acknowledges that the real goal is to try to keep things in a well-architected state. In order to do that, you will find yourself negotiating between the pillars. That's why I encourage you to stick around for all of the sessions, not just the ones for subjects you're immediately involved with, because you'll see them all show up on your doorstep at some point. With that, let me tell you a little bit about the event. Following this keynote, we'll have 5 separate 15-minute sessions with live Q&A after each. They're all going to be fantastic. So allow me to welcome you to behind the scenes at Azure here at Well-Architected, the Backstage Tour.
And with that, we are ready to go with our first session. And so we're going to start in a session where the service that we're talking about touches more people than you might imagine. And I know that Daniel's going to be able to tell you all about it. And I know we all care a lot about reliability. So with that, I want to hand you over to Daniel.
Awesome. Thanks, David. Well, hi, everybody. My name is Daniel Gickelhorn. I'm a product director in the global networking team here in Azure. And in this session today, I'm going to take you backstage with Azure Front Door and show you how we use the set of global vantage points that Front Door is deployed at on Microsoft's global network to self-heal and to optimize a set of user experiences for services that are using the Front Door platform. I'm going to get started by setting some context about Front Door in general before I take you behind the scenes, just so that you understand a little bit more about the service. So to get started, Front Door is a versatile service that helps improve the security, reliability, and performance of an application. It is deployed across our global backbone to about 180 edge locations around the world. And it's placed strategically about 30 milliseconds away from end users to best optimize the user performance, connecting through from end user devices out on the internet, through the edge of our network and down into Azure where your applications are running. Front Door plays a really key role in cloud architectures by serving a perimeter security role to control access to an application and protect against constant and sort of known threats. It serves as a global load balancer that can help you bake reliability into your application and fail over in case you have some sort of regional failure. And it provides content and application acceleration to improve the performance of either content you're delivering to websites or any kind of applications that are HTTP based that you're running on Azure. Front Door is not a new service. We've been developing it for the last 8 years, and now about 80% of Microsoft SaaS services that you're probably also using today run on Front Door behind the scenes. And it's a platform that we're developing very quickly, and we're expanding to new locations around the world. We've recently deployed quite a bit in Africa, including in Morocco, and we're deploying about 1 new edge site per week on average to expand this global footprint to even more locations. Front Door works by having a set of global vantage points, meaning deployed in metros close to end users, and it's connected to our global data centers via Microsoft controlled fiber. This gives us a reliable path between our edge and local metros where devices sit and our data centers. And Front Door really serves as the bridge at those sites between end user devices and the application sitting on Azure. Front Door uses Anycast technology to drag traffic into the closest edge site, meaning it localizes it to the closest location. And then it can see the full path end to end from that edge site down to the data center. So when it serves as a global load balancer, it can make decisions about what's the best, both reliability and performance-wise, location or backend for it to route traffic to. So it can determine if there's some sort of application failure all the way through the infrastructure from the edge down to the application. If it does detect an issue, it can start to route traffic around those issues, and it can help an application auto heal. So if you have multiple regions, if you're deployed in multiple regions, then it can help you fail over across those very quickly. The way it does this, it uses HTTP instead of DNS. So effectively, it is able to make decisions much quicker. DNS has this challenge where due to the fact that it relies on wait times or TTLs to fail over, it can often take a long time to actually fail over across different backends. In particular, this is worst with enterprise and mobile networks. And what I'm showing on the screen is an example of this, where it took about an hour to fail over 95% of the users for this application after an incident. And that means a lot in terms of the user experience that customers get when delivering their application, and how a service behaves performantly and reliably during outages or during failovers. It does this because, as I said, it's an HTTP service, and it doesn't change the client IP when it fails over. It instead just makes a routing decision to move traffic across backends, and this can really help building individual applications. Behind that is a complex global system that Front Door sits upon, and what I talked about so far is really the reliability that can help at the app level. Going behind the scenes, a part that's not seen as well is how Front Door really heals end-to-end, which includes the portion of Front Door's application that controls and manages the connectivity between end-user devices out on the internet and Front Door itself. And these are things that are generally outside the Microsoft network and more difficult to control. It starts with, as I mentioned, Anycast that helps us auto-heal connectivity coming into Azure and make sure that we can route around connectivity issues that happen out on the internet quickly when possible. But it has another trick up its sleeve where it is able to actually see this path between end-user devices and Azure itself. And it's able to act to mitigate even partial failures or gray failures across that path. So I'm going to get a little bit deeper into that. So the system we use for this is called Map of the Internet. It's deployed, in fact, in many Microsoft products that you may be using today, Office, Windows, others. It is a service that collects information about network telemetry and monitors global internet performance and user experience when it comes to the internet or network connectivity across hundreds of millions of devices in real time. It's connected to our global WAN, and in the case of degradation, it is able to make decisions based on what expected client performance should be. It can disambiguate between wired and wireless connections and networks. It can determine whether an issue is sustained or transient, and it can make decisions to fail traffic over across different paths if it has them available. So it takes this data. What you're seeing on the screen is, in fact, a map of one day. Every green dot is a sample data point that we plotted, but one day of users sending information into this system, and it's done in a privacy-centric way and very carefully, but provides us a really clear view of how do we deliver the most reliable and performant services on the internet, and how do we take applications that are running on Front Door and make them more performant and reliable. So this data comes in, it's turned into a set of signals, and we group all of these users by their geographic location and the infrastructure that they use to connect to Microsoft, either the networks, ISPs, and things out on the internet. That data then goes through a set of machine learning algorithms that process that data and decide if there's an alternative path available, can we take it? Based on that, our network makes automated routing decisions to move traffic around degradation when it can. And that provides a level of auto healing for us so that in the case of these sorts of issues, we can effectively route around even partial failures out on the internet, which happen incredibly frequently, in addition to large-scale internet outages, which happen quite frequently as well when you start to operate with services that look at every geography across the globe. So that's the map of the internet. It's something we've been developing alongside Front Door for a while, and it's something that if you're using the Front Door platform, you don't necessarily get to see up front, because it's doing it behind the scenes to make your application experience better. What I'm going to talk about next is how do you use a similar service or part of the map of the internet service for your own applications to make decisions, leveraging the technology just with your own data. So let's pretend to start that you're operating a service that has users in many geographies in a given region. You have users that are distributed across a wide area, some on desktop devices, some on mobile devices, and you're trying to understand the difference between those users. So let's pretend you get an email from your leadership that says, hey, I want to understand the difference in performance when I make some sort of network decision or something that will change the performance of web requests going to one endpoint or another. Say you're deciding on using new security services, or you're trying to make a decision going from on-prem to cloud. What are the changes in performance? Internet Analyzer is a service that we've provided. You can access it through the Azure Marketplace. And effectively, all you have to do to use it is sign up. It'll give you a link that you embed in your web experience. It is limited to web experiences today. But once you've done that, you deploy a small image to the 2 different web endpoints or experiences that you have. And that way we can basically pull that image as a test object. And effectively, the Internet Analyzer service moves that, with views of your web page, distributes that JavaScript to your end users, and then runs a series of tests validating the performance between various different endpoints. That then gives us information to share with you, and we move it into a central location where you can then consume it yourself. What you get is a set of scorecards that help you make decisions, both in terms of monitoring behavior over time, as well as information about the differences between, effectively A/B endpoints in your test. This is something that we use internally to make decisions and part of the map of the internet service itself as we start to look at changes in the network. But it's something that we've exposed to you because we know that, reliability, performance, platform management is really key. And it's something that you don't have to look at just at a global scope, but you can actually drill down and access it at a regional scope as well, or be able to split it by country. So that's a quick look into the Azure Front Door service and map of the internet and how it helps behind the scenes to improve the reliability of services that are using our cloud products like Front Door. And thank you for your time. There's a few links on the screen right now that'll help you get more information. And thanks for taking the time with me.
Hey, Daniel, this stuff is super interesting. We have a bunch of questions in chat. I'm wondering if you could stick around so we could ask you for like a good, 5 minutes, maybe even more, if you're up for it.
Absolutely.
Okay, so the first question I have to admit I want to ask, based on the things that have been submitted to us, is somebody asked, and I'm curious about this too, when you say that Azure Front Door helps us route around outages, like what kind of outages are we talking about? Like what do we actually handle?
Yeah, that's a great question, David. So there have been many different types of infrastructure outages that Map of the Internet has helped us route around in the past. Everything from fibers being dragged off the seafloor to the Super Bowl or large-scale sporting events that congest the internet and cause internet service providers to show degradation, to Microsoft itself having regional issues and things like that allow us to detect those and make decisions quickly to mitigate.
Okay, cool. Well, so there's a follow-up kind of product-y question that I want to ask. Somebody is asking, thank you very much for your question, Rixar. Is Azure Front Door like other CDNs? Can it be used like other CDNs, like some of our competitors, like Akamai and other people like that who do CDN stuff?
Yeah, also great question. Yeah, so Front Door is itself a CDN. It's something that we grew out of Microsoft's enterprise roots. And so it is something that from a, sort of CDN competency perspective is a place where we started. It is a general purpose platform. You can use it like other CDNs, but it's something that we continue to develop on, really focused on cloud first scenarios and cloud native access, agility, and management that will, something that we will build on over the next few years as well.
Cool. Okay. And to go a little slightly more technical, someone is asking, Deshaun was asking, where do we find latency benchmarks for Front Door if they want to do that? I wonder if this has to do with the Internet Analyzer stuff that you were talking about as well.
Yeah, so that's something that we do have coming soon. There are a couple sources out there that have done latency benchmarks independently. We're currently working with a couple of different providers as our new version of the products, Front Door Standard and Premium, come out early next year to provide more standardized public latency benchmarking.
Cool. And by the way, those little bling noises you hear are, because I get them too, are people asking questions. So we're going to do our best to get as many of the questions as we can during this time before we have to move over to our next session. So let's do some more questions. Here's a really fun one from Andre. What kind of clients are setting the telemetry for map of the internet? Like, where are we getting that data from?
Yeah, also a great question. So there are a combination of different, basically rich and thin client experiences. It's deployed in Windows builds that are more recent. It's deployed in Office, but also in a collection of web experiences. And so the diversity of different types of clients that we have sending us information, again, in a very privacy-centric way, gives us the ability to see, very basic web experience telemetry all the way up through, what you'd be experiencing connecting through, say, an Outlook or a desktop-based application in Office.
And I know that I'm kind of excited the fact that we can take like all that data and with Internet Analyzer and with just the routing functionality, use it for good. Like it's really cool it's cool to collect data, but it's even cooler to actually use it for like people's best purposes. Okay, so more questions are coming in, but we're gonna have to wrap very soon. I guess the next question that I see here, and then maybe we'll wrap and we'll start moving towards the next session, is one around expansion. You had said something about the fact that we're expanding the network, the points of presence. Can you say a little bit more about that? I didn't remember the exact stat you gave.
Yeah, so right now we're expanding at about one new site per week. Sometimes those are in existing metros for reliability. Sometimes they're in new metros. We've gone to a lot of new geographies in the last 18 months. We continue to expand. Part of the benefit of the Map of the Internet service gives us visibility into where we should expand to improve user experience. And so it is a place we're making lots of investments. If you saw the map that I shared on the second slide, there are a lot of places in the globe that still don't have little white dots. And as we expand to meet more users where they are, we will continue to move both our CDN, our front door locations, as well as our global network into lots of new metros over time.
Awesome. Well, we got a bunch more questions. They're in the chat. If you have a moment, Daniel, really appreciate it if you would drop in the chat and answer. I know you've been on camera, so it's kind of hard to do both at the same time. Thank you so much for this behind the scenes at this sort of stuff. So with that, I think we can say thank you very much for reliability. And now we get to move on to another pillar of the well-architected framework. So for this pillar, we have something that I know everybody cares a lot about, which is security. And so it's my pleasure to bring on Rod Trent to talk a little bit about another one of these high-scale things where there's lots and lots of data being used for really useful purposes. So with that, I'd like to introduce Rod Trent. Rod, will you tell us all about security stuff?
Thank you, David. Thank you so much. Absolutely, I will. You actually almost caught me taking my own notes from that last session. That Map of the Internet stuff, we're talking about signals today, or threat intelligence. So that last session was actually kind of unique and gave me some ideas and some things we can talk about maybe at a future session. But anyway, thank you so much for that. Hi, everyone. I'm Rod Trent, Senior Cloud Security Advocate for Microsoft. I'm here today to discuss how Microsoft takes a seemingly obscure reference to something and turns it into security intelligence that benefits your environment. So welcome to the secret life of a security signal. In this session, there are 4 top goals which are important to highlight before we start digging into our discussion, okay? So first, we'll explain what generates a security signal. Then we'll talk about the state of security and why it is so important that we monitor these signals in our environments. Next, we'll give some insight into how Microsoft takes these signals, tunes them, and gives them back to customers. And finally, we'll learn how any customer can use these signals for monitoring security for their own environment, okay? So, what better way to start our discussion today but with a story that we're all probably familiar with. I mean, we've at least heard stories on TV and in the movies, technical articles, and probably breaking news stories or what have you. And for some, this hits home because you've had to deal with this directly in your own environment. It happens every day. There's a specific activity in your company that needs to be monitored. In the event, there's the potential for compromise. This activity is a normal activity, but it stands out because this normal thing that your users do every day has a different payload attached to it this time. It could be malware, it could be ransomware. So here's the common scenario. A user opens a legitimate looking email. The user clicks on a web link in the email, as users do, and is whisked away in the web browser to a website that also looks legitimate. However, upon further inspection by the security team, the email did not pass the legitimate muster. And unknown to the user, the website is part of a potentially suspicious domain that's already probably been reported somewhere. Once the website was accessed, a download was initiated in the background. The user never even knows about it. But sure enough, after that secret download, a process on the user's device is initiated and something was installed. Even if this ultimately turns out to be nothing, we still want to know about it. To be able to secure our environments, this type of activity, whether innocuous or not, needs to be recorded and monitored so all our digital assets can be protected. Have you ever wondered how this type of activity gets recorded and then cataloged as a threat so that the rest of the world knows about it? And then how it's taken and turned into a security signal that's available across all organizations. Okay, so let's spend some time talking about that, and let's see how all these efforts are integrated together so you can take advantage of these signals in your own environment. Before we dig into the discussion about the path that a threat signal takes from, let's say, farm to table, or from user activity or signal to threat intelligence, let's discuss why it's important that this happens. Security is a constantly moving target, right? Threats are constantly evolving because as these security signals are turned into threat intelligence, threat actors keep altering their methods of attack to keep up. Threat actors evolve right alongside the threat intelligence that's built to stop them. Let's look at some of that evolution, okay? Mass distribution malware has been with us for several decades and is still a basis for what we see today. It's an attack method where an attacker really doesn't care. It isn't specific about the prey, but is only an attempt to locate an unsuspecting target by casting as wide a net as possible. Mass distribution malware has evolved into malware that is now targeted at individual organizations. The attackers have gotten a bit smarter. The past few years have seen an increased investment by these threat actors into trying to evade file-based detection using things like PowerShell to load attack code directly into memory. And now recently, we have seen the rise of live off the land attack campaigns that involve literally no malware at all. These frequently target online software as a service such as Office 365 and involve methods like social engineering, credential theft, and have native platform capabilities like document downloads, forged emails, delegation forwarding rules, PowerShell scripts, and as a result of that user clicking on that link in that email. And this is just an example of some of the evolution of some of the current attack vectors, okay? So hopefully we can agree here it's important that these threat activities are monitored using some unique and comprehensive method to expose user activities when they represent actual threats. So immediately, right, we get a sense that it's absolutely critical that our threat intelligence stays one step ahead of these threat actors. Microsoft is constantly collecting threat signals and turning them into valuable threat intelligence that can be used by our customers. Let's talk through how this process works. Microsoft's Intelligent Security Graph is a series of interconnected systems that enhance Microsoft's security capabilities through three separate but conjoined and correlated areas, which are data, machine learning, and human insight. We have learned that successful use of threat intelligence requires a large, diverse set of data and extensive integration into your processes and tools. At Microsoft, We have invested in both of these so that our customers can take advantage of it. At the current time, think about this, Microsoft processes over 6.5 trillion signals each day. Through the use of our services like Office 365, our customers are generating these signals. Through these signals, Microsoft has an unparalleled view into cybersecurity activity that gets turned into threat intelligence and fed back into our systems so our customers' environments are protected. Effectively, think about this, the more of our services our customers use, the more protected they will be. And in that respect, through the use of our services, customers are helping to protect themselves. So I bet you didn't know that Bing is a security tool because it's designed to generate signals. Want to better protect your environment and at the same time limit how advertisements creepily kind of follow you around the internet and your mobile devices? Use Bing as your search engine of choice. On top of all that, we layer shared threat data from our partners, from the 3,500 plus full-time security researchers here at Microsoft, from law enforcement agencies that we partner with worldwide, as well as botnet data that we collect through the digital crimes unit at Microsoft. All of that intelligence makes up this intelligent security graph. Centralized visibility is important. Many of our customers are familiar with the consolidated security console at security.microsoft.com, hopefully by now. Heeding customer requests, we put forth a mighty effort to consolidate our security platforms and properties into this central location. This brings together things like our Defender, Office, and MCAS products, among other things, among other security services and platforms. But for true centralization, there's two aspects of our cloud services that provide a holistic, overall view of security signals in the environment. Azure Security Center and Azure Sentinel are different capabilities with complementary purposes, okay? Azure Security Center is focused on protection and governance of Azure workloads by accessing risks to them, reducing the attack surface, and generate alerts on potential threats using advanced threat detection techniques. The roles that use Azure Security Center will typically include people like security engineers and governance, risk, and compliance professionals that report to the CISO. Azure Security Center also supports on-premises and multi-cloud platforms so customers can gain that same insight from their entire environment. Azure Sentinel is focused on monitoring all environments. Azure Sentinel allows for monitoring alerts and security-related events from any source, Microsoft security solutions, third-party, custom rules, multi-cloud. Azure Sentinel is built for security operations centers, both analysts and the managers, to make their work easier and more effective. Like a sluice box, Azure Sentinel can catch any remnant of any potential threat to the environment. And even those services at security.microsoft.com and the assets that's monitored by Azure Security Center, they can all be connected to Azure Sentinel to supply a single centralized console for literally everything. Okay, so there's yet one more piece of this signal development path that might get overlooked, but is equally, in my opinion, important. It's also somewhat revolutionary in the way that it works. Azure Sentinel is built on technology that allows easy, secure sharing of content. This enables organizations that use Azure Sentinel to develop their own collateral for monitoring and exposing the latest threats, and then making those available for collaboration to teammates, colleagues, and even other parts of their organization. This capability also provides value from us, from Microsoft, to our customers. At Microsoft, our products follow a defined DevOps pipeline, ensuring that any updates or feature enhancements, or even these new threat intelligence signals, can be supplied directly to our customers. A couple great examples of this are provided in some recent publicly known situations. First, in the case of the SolarWinds security flaw in early 2021, if you remember, Microsoft was able to deliver guidance and monitoring capability directly to our customers through Azure Sentinel in a matter of hours so that our customers could identify whether or not they were impacted. Secondly, even more recently, in the case of the recent Kaseya and Print Nightmare situations, Azure Sentinel customers were able to quickly develop their own intelligence to protect their own environments, and then share the collateral and knowledge with others in the Azure Sentinel customer community to enable them to protect theirs. So customers are never alone. We're all in this together, whether it's through their partnership with Microsoft or through their participation with their peers. Microsoft customers can rest assured that the best approach to organization security is full of wealth of knowledge that is shared and not hoarded. As you can imagine, Azure Sentinel follows the same DevOps pipeline that all of our products follow within Azure, okay? We use GitHub as a piece of that pipeline. Most of the content provided in the official Azure Sentinel GitHub repository is fed into Azure Sentinel automatically, so Azure Sentinel customers have the ability to utilize the most current signals immediately when they're available. But there's also some content here that has been supplied for specific purposes. The recent SolarWinds situation is a great example, or has been supplied by our customers or our partners in an effort to crowdsource security coverage. If you go to aka.ms/asgithub, you will see folders and files for detections. We've made the process for utilizing these signals extremely easy, okay? Let's walk through this process to see how easy it is and how anyone can do it. While customers can use APIs, PowerShell, and other methods to automate the process, let's look to see how it's done through the user interface to get a sense of how intentionally straightforward it truly is. Because at Microsoft, we believe securing the environment shouldn't be complicated or demanding. It should be inclusive and effortless and shouldn't demand the resources of a developer. All right, so I'm going to grab my demo environment here really quickly. I have two tabs open here. I have my Azure Sentinel console. I also have our GitHub repository that I just talked about. As an analyst that uses Azure Sentinel, I'm going to go into the detections folder and I'm going to look for things in here that are of interest to me. As a security analyst, I know that most of the things that I'm concerned about are user habits, or might we say bad end user habits. So Office activity generally captures that for us. Let's find something that looks of interest. Here's one called Rare Office Operations. I start to take a look at this, gives me the description, tells me what it is, gives me all the information I need to kind of create my own rule here. So this is amazing and awesome. So now I've found something that I absolutely want, and I want to include it in my own Azure Sentinel console. I want to be able to identify this within my own environment. I'm going to go to the analytics rule blade within the Azure Sentinel console. I'm going to go ahead and create a new scheduled query rule that does absolutely what it says. It runs on a schedule and goes and looks for that thing that I want it to go look for. In this case, I want to look for rare and potentially high-risk Office operations, which essentially means an end user is doing something in Office that they don't regularly do, or maybe they've done it a multitude of times and maybe they shouldn't be doing it that way. The first thing that I want to do, which is an absolute extreme value, and people kind of overlook this as part of value of GitHub, there's this raw button right here, right? So this is all good. This is some pretty data here. I love the green color, and that I think that's kind of light blue, sky blue, or cloud blue, should we say, since we're talking about the cloud today. I want to click this raw button. This raw button is hugely important. What this does for us, if you've worked with code or queries or things like that that you copy and paste from the internet, you know that when you do that, there's the tendency to capture bad characters, bad formatting, ghost characters, and things like that that can stop that query or that piece of code from working properly. But in this case, this raw button, it sanitizes this query for us. So by the time we want to take this query and do something with it, we know that it's clean, it's going to work right off the bat. So I see a few things here, right? We've gone back to the analytics rule. We see that it's asking for a few things. It's asking for a name, description, the MITRE tactics that are associated with it, the severity, the recommended severity for this case here. All of this is contained within this analytics rule on this GitHub repository. So at this point, it just literally becomes a copy and paste operation. I wanted the name. I'm going to go back to my console. I'm going to paste it in, right? The description, yep, absolutely. Look at that. The description is there for me. All of this recommended guidance, which is hugely important for completing my very first analytics rule. The MITRE attack tactics, right? These are all of those part of the escalation chain, helps us categorize so we can work on and severity and where we can put our security focus, right? So the MITRE attack chain down here, the tactics are actually listed for me as well. Persistence and collection. I can adjust that. And collections down at the bottom. I have those set accurately. This severity is recommended as low. Over time, as a security operations team, I may determine that, I want it to be medium or high level severity, but let's just choose the recommended severity there. Also, the query, the logic behind what is going to happen here that's going to go out into the data that I'm collecting in my environment, that is included in this KQL query. Everything else that I need here as far as how far back that the data is looked at and how far back and how often that this schedule runs, it's all provided here, which is absolutely important information for me to be able to complete this, right? There's some other things that we can do here. We can also automate some things. Azure Sentinel is a security information event management system, but it also has that SOAR capability, or that security orchestration automated remediation built in here, so we can automate things if we want to do that in the future. But it's very easy, like I said, as you can see, to go to our GitHub repository, find something that looks valuable for our organization, and I can create it myself. Over time, I can go back into this analytics role and evolve it on my own. All right. Lastly, okay, customers don't need to wait for us to supply an analytics rule based on a new threat. Using the same KQL or Kusto query language that's available from our GitHub repository, you can develop the logic around your own custom analytics rules. This capability enables customers to develop their own detections based on what's most critical to their environment. It also supplies our customers the ability to monitor for newly reported threats for which threat intelligence doesn't even yet exist. Okay, creating custom analytics rules is the same wizard-based walkthrough instructions, except now each wizard field will need to be supplied. The instructions are supplied here. You can see that in the link. Additionally, some knowledge of the KQL query language is a must. In this slide is a resource link to guided KQL learning that's part of the knowledge necessary to pass the SC 200 exam, Security Operations Analyst Associate. Finally, here's some additional resources that should prove useful for our discussion today. And I'd be a bit remiss if I didn't mention, but my father passed away in the wee hours of this morning. My teammates here, they know that. He was a wonderful dad, teacher, mentor, grandfather, and recently, just recently, great-grandfather. So he had it all, a wonderful, rich, and full 86 years, a life well lived and worth living. I can only hope to be as life-rich as he was someday. I'm truly blessed to work for Microsoft, though, a company that cares about its employees and their mental health and wellness. I could have skipped this presentation today, and someone probably more fantastic would have delivered it. But my dad was always proud of me and my work. He always bragged on me, even through my difficult years, right? It's the way dads are. As kids, grandkids, great-grandkids, and friends and other family gathered together in his home last evening, knowing it was kind of our last goodbye, I determined to actually be here today. So my participation in this event today is absolutely in tribute to him, a tribute to my dad, Porter Trent. David, back to you, good sir.
Sorry, I'm tearing up also. Rod, I'm really glad that you could be here and you could be able to deliver that in tribute to your dad. He obviously did an amazing job raising you. So I think we probably have to go back to security because there's a whole mess of questions about this. One of the ways you can tell a really good talk like the previous one is that there's tons of questions in the chat. I'm wondering if we could steer this a little bit back to this with again, also, I think, and quite frankly, in tribute to your dad, to answer some of the questions, because I think he would have really dug this part too. Were you up for that?
Oh, absolutely.
Okay, so let me sort of, because they're streaming in fast, so I'm going to do my best to catch as many as I can in the time that we have for Q&A. So let me ask sort of a question coming from Idris, which says, do we need to add Azure Firewall even that all services will be PaaS offerings? So I guess the question is where does Azure Firewall fall into what we're talking about here?
So from these signals, so understand that every Azure service, even our on-prem services and things like this, consider that every transaction, everything that happens within any environment, even our Azure services are absolutely the same. Whatever transaction is done, whether it's the firewall communication, whether it's some Windows update or something like this, that is logged somewhere, right? So there's a log that records that. That's part of that signal gathering process. And what we do, we talked about a little bit toward the end there about creating your custom rules around those scenarios. As long as we can get that log file to something like Azure Sentinel or Azure Security Center, that signal is available for us to look at the logic of how we expose that as a potential threat. So everything even that happens within Azure Firewall is going to be recorded, sent to our central location, and then we can react or act upon it if it happens to be an exposed threat.
Okay, cool. Okay, next question from Andre. He's curious, he or she or they're curious, what is the connection between intelligent security graph and Azure solution architectures?
So from that perspective, consider that as you are deploying and rolling out Azure workloads, for a lot of customers that are either mid-migration or maybe they're just thinking about migrating, this is, for a lot of customers, and I've heard this quite a bit, this is their chance, right, to start fresh, start kind of new in some respects, but also start secure. So by utilizing that intelligent security graph and those signals that are exposed and developed and made available for us, as we use something like Azure Security Center, you move a VM workload from on-prem to the cloud, we're going to give you those recommendations as you deploy that, how to deploy that securely. It's kind of a best practice based on what we know and what we've done with other customers. Obviously, it's going to be up to you and your approach and perspective for security for your own environment, because you understand your environment better than we do. But at the same time, these recommendations are going to be made available, and not just at the time of migration and deployment, but it's a continuous recommendation cycle. So VM gets deployed today, you say, okay, I'm going to go ahead and accept these recommendations. But as things happen over time with that virtual machine, updates might get missed, or maybe a port gets open for, we've installed an application, some weird application that needs some crazy port open. We're going to continuously monitor that and give you more recommendations. Say, you're kind of out of bounds on this one. You might need to make some adjustments.
Cool. Okay, so the next question that came up is one that I suspect is good for the product team. And I know you talk to them a lot, but I'll ask you this, and maybe you could just say, yeah, this is a great idea. I'll pass it on. So Norman was asking, is there a plan on adding a button to make a query a scheduled rule? Which sounds like a great idea to me.
Make a button to make a scheduled rule. So just based on that question, the surface of that question, we have different types of analytics rules that you can create. Scheduled analytics rules, the one I talked about today. As far as a button, I think that's probably, if you're more a fan of dialog buttons versus little drop downs, I'm sure we could probably talk the product team into that. One of the things I would recommend as part of that, though, because we do have some official channels for recommendations and requests and things like that, I would highlight and highly recommend our security private preview program for any customer. I didn't include this as part of my resources, but if you go to aka.ms/securityprp, any customer can join the private preview program. What that does, which is absolutely amazing, gives you direct access to things like the roadmap for the security products, gives you direct access to our product teams who look at those types of recommendations and requests. You can make those requests and get a formal official response that, hey, this is absolutely awesome, or we'll take this under review. So that's the best way to handle that.
Awesome. Well, we're running out of time, and I know that the chat is on fire, is the way it was described to me in terms of the questions that are coming in. I hope you will stick around for just a little bit if you have a moment. You and the team to take a look at what we have there. I know that this session blew my mind when I first heard about it. When I first heard that, look, we take billions of security signals in, and you can see the output of that in a GitHub repo that everybody can reach, blew my mind. And so I'm so glad to be able to present this to you. But I think we actually have to move on to another pillar. So thank you, Rod, for being here. And again, really sorry for your loss. And I really do appreciate you doing this, and it's tribute to your dad. So thank you.
Thank you so much. Thank you.
Okay, so with that, we have to move on, believe it or not, to the next pillar, one that I know people care a lot about, which is cost optimization. So for this pillar, it turned out to be a little hard to get the experts that we wanted to be here live for this particular session, though they will be able to ask Q&A. So we decided to go ask them these questions anyway, and to go behind the scenes with them by going into the studio and talking to them that way. So I'm going to switch out of the live mode, and we're going to cut over to the studio where we had a chance to talk to Ritesh and Priyanshi about cost optimization. Hey, so welcome to the cost optimization session. So this is 2 reasons why you should believe us when we say you can optimize your Azure costs with Ritesh Kinney and Priyanshi Mittal and me, David Blank-Edelman. So when we were looking at the cost optimization question, we thought, let's provide the thing that is most useful to our customers. But how are we going to know that? So we decided to look at the data for Azure Advisor, which gives recommendations to our customers on how they can optimize their costs and get the most value for what they're trying to run in Azure. So when we looked at those and we looked at the top recommendations that Azure Advisor gives out, we saw that there were 2 that stood out that we thought we should talk about. So let's go take a look at the first one. Okay, so let's go into Advisor and see what recommendations we have. So the recommendation we're going to talk about first today is this one right here. Right size or shut down underutilized virtual machines. So I thought I'd bring to the studio an expert on this. Hey, Ritesh, I'm wondering if you could talk a little bit about right sizing.
I would love to. Let me jump right in. So here's an example of a recommendation that we show for virtual machines for right sizing. In this specific example, we suggest that you can change your Reco test VM from a D16 V3, which is a 16-core VM, to a D4S V3, which is a 4-core VM. In doing so, you will save $10,000 on yearly Azure costs. Not bad for a single recommendation, right? Let's walk through how we produce this recommendation. First, we start by looking at the utilization of each VM across the Azure fleet. Don't worry, we have no idea what you're running on this VM or who's running it. We just boil down the telemetry to CPU, memory, and network utilization in the form of percentages. This chart shows the utilization over the last 7 days. As you can see, the utilization of CPU, memory, or network never goes beyond 28% in this case. The shaded red area represents underutilization, which in this case takes up majority of the chart. The workloads running on this VM simply don't need the power that this VM is capable of. Another way to look at underutilization is with buckets. Let's say this is the utilization over the last 7 days. It comprises of data points collected every 30 minutes. And over 7 days, that translates to 336 data points. For ease of calculation, we just take the 95th percentile while figuring out our recommendations. The 95th percentile considers most of the high load while ignoring some non-typical spikes. Let's say in this case, the 95th percentile of CPU is 10%. Similarly, this is the utilization of memory over the last 7 days. However, in the case of memory, we take the 100th percentile, or simply the max value observed over the last 7 days. There's a difference in the percentiles that we consider for CPU and memory, because most workloads can handle the CPU peaking out. But if the memory peaks out, there is a risk that workloads can crash due to out-of-memory exceptions. Performance and reliability is the number one thing that we think about while generating our recommendations. We want to make sure that those aren't impacted at all. So the P100th of memory in this case is 9%. We can represent the total capacity of virtual machines in the form of buckets, such that if the bucket is filled up, it means that the resource is being utilized completely. In this case, since the P95th of the CPU is 10%, the bucket is filled up only at 1/10 of its capacity. And memory is filled up even lower than that. As part of our right size recommendations, what we're trying to do is get you to move to a smaller size bucket such that the utilization is increased and the empty space in the bucket is minimized, while at the same time making it cheaper for you to run your workloads. The D16V3 is a 16-core VM with 64 gigs of memory. We can quadruple the utilization of the workload by moving to a VM that is 1/4 the size. So by moving to a VM that has 4 cores and 16 gigs of memory, the CPU utilization can be moved from 10% to 40%, and the memory utilization can move from 9% to 36%. Similarly, if we go to an even smaller size, the utilization can go up even higher. Thanks to the number of SKUs available in Azure, it ensures that we always have enough sizes to choose from. So how do we land on the right size to choose? As the title suggests, it's with the form of targets. We identify what we want the ideal max utilization to be based on the type of workload, and then try to choose a size that gets the utilization up to that target without going over. You might be wondering what is user-facing and what is non-user-facing, or you might be wondering how do we even know what is user-facing workload and what is a non-user-facing workload? I'll answer the first question first and discuss the second question later, because that's where some of the magic really happens. User-facing simply implies that it is processing user requests directly. Non-user-facing implies that it is processing batched or scheduled requests. User-facing workloads are more critical in nature because they are directly processing user requests, and that's why they have a lower target of 40% for CPU and 60% for memory. Non-user-facing workloads have a target of 80% for both CPU and memory. This is how we finally land on the right size to recommend, by figuring out the size that gets you closest to the targets. So now let's discuss how do we know if a workload is running user-facing or non-user-facing. So this is the magical part. Our super smart friends in Microsoft Research did some investigation and found out with high degree of confidence that it's possible to categorize a workload as user-facing or non-user-facing simply by looking at the waveform of the load average of the VM. They've published this paper where it has some very interesting details on how they came up with this research and how they landed on the conclusions. Definitely check it out. It's extremely interesting. So now let's go back and figure out how we come up with the recommendations that we show in Advisor. We start with collecting the utilization information. We get that from the Azure host machines that run the VMs. Again, we don't know who the VMs are run by and what kind of workloads are being run. We simply know, what the CPU, memory, and network utilization is. The metric information is sampled at 30 seconds and aggregated over 30 minutes. When we're aggregating, we take the max values just so that we're ultra conservative when we come up with the recommendations. As always, we don't want to impact performance or reliability when you adopt our recommendations. Finally, we consider the last 7 days of utilization while figuring out our recommendations. So now let's look into exactly what happens to derive a recommendation. We first compare the current utilization with the capacity of the VM it's currently on. We identify the type of workload it's running, the user-facing or non-user-facing part, and figure out what the target should be based on that workload. Then we'll take a look at all the different sizes available in Azure and see which size can get the workload to the right target utilization. We don't want it to go over. It's going to be as close to the target as possible, but not go over. And then finally, we pick the cheapest option so that you get the most cost optimization while keeping the performance and reliability intact. So finally, what we land up with is a recommendation that moves the utilization from something like this to something like this, which means you get to optimize your costs while keeping your performance and reliability intact. Pretty cool, right, David?
Yeah, that's really cool. Well, so I would like to also take a look at a second recommendation here since we're on a roll here. Okay, so let's go back into Advisor and see our second recommendation for this session. So this recommendation is buy virtual machine reserved instances to save money over pay-as-you-go costs. So I'd like to bring another expert on to talk a little bit about reserved instances. Hey, Priyanshi, I'm wondering if you could tell us a little bit about reserved instances.
Hi, David. Absolutely. Let me jump right into what are reserved instances, or also known as Azure reservations. If you have consistent VM usage that supports reservations, buying reservations give you the option to reduce your cost with same configuration, same reliability, and same performance, but reduced costs. For example, when you continuously run instances of VMs, you are charged at pay-as-you-go prices. When you buy reservation, you immediately get that reservation discount. The resources are no longer charged at pay-as-you-go rates, and Azure reservations help you save money committing to 1-year or 3-year plans for multiple products. Why would you buy reserved instances? They save up to 72% on your pay-as-you-go costs. After you purchase a reserved instance, you don't have to redeploy. The discount is automatically applied to matching resources. You can commit to 1-year or 3-year plans wherever available. It's also an advantage for our Azure teams so that they can optimize the capacity planning for VM instances effectively. Now let's look at what data points we use in the recommendation engine to get the right recommendations for you. If your resources are shut down regularly, the simulation won't find any savings and no purchase recommendation is provided. So it looks at currently deployed resources for VMs. It takes into account any special discount that you may have on your pay-as-you-go or on-demand prices. It looks and aggregates usage across multiple days, including 7, 30, and 60 days. It also considers any recent reservation purchases that you have. And lastly, it also calculates usage for each and every Azure subscriptions. Then it provides recommendations with projected savings and potential projected usage and potential savings. Now that we've looked into what data goes into the system, let's also look at how these recommendations are calculated or simulated. The recommendation engine evaluates the hourly usage for your resources in the given scope over past 7, 30, and 60 days. Based on the usage data, it simulates cost with and without reservations. The costs are simulated for different quantities, and the quantity that is recommended maximizes your savings. The recommendations in Advisor are based on single scope and are based on last 30 days usage. Let's look at a very simple example here. So in the chart, you see that your VM usage fluctuates from using 35 VMs to up to 70 VMs every hour. Now, how would the recommendation be calculated since it's been fluctuating a lot? So the recommendation looks at the most consistent usage. So in this case, though the most consistent usage would be around 40, it may recommend the quantity to be 45, because though the utilization of the reservation might not be 100%, but it will give you the maximized savings. Now, how do I get these recommendations and how do I purchase these VM instances? VM recommendations are available in Azure Advisor. Recommendations are also available in reservation purchase in Azure portal, and also in cost management Power BI app, and you can also get them through our APIs. When purchase the quantity that Azure recommends, that will give you the maximum savings possible. The recommendation quantity and savings are for a 3-year reservation where available. If a 3-year reservation isn't sold for the service, the recommendation is calculated using 1-year reservation price. Isn't that cool, David?
Yeah, I find all these things really cool. Like being able to see behind the scenes how we calculate this stuff is really super interesting. So if our folks watching this want more information about what we've been talking about, both about right sizing and reservations, they can check out these docs on Microsoft Docs. And I want to bring Ritesh back, if we can, for a moment. So I think that people who are watching this live are going to have questions for you. Would the two of you be willing to answer some questions from people?
100%.
Great. Okay, so let's
Absolutely.
switch back to the live. Let's switch back to the live environment. It's a little eerie seeing yourself there. Anyway, welcome back to live. So let's just do a really quick review here. We have just talked about the thing that powers 80% of our SaaS offerings. We have just talked about billions of security signals that will eventually wind up in a GitHub repo you can use. And now we're talking about how you can save money really easily and how we give these recommendations based on all the data we have. So I would really love to be able to ask a bunch of questions because the chat is on fire and it makes me so happy that people are into this stuff. So if we could bring Ritesh and Priyanshi on, that would be awesome. You folks ready to answer some questions? Because boy, do we got some.
Absolutely.
Great. And Ritesh, I think you're muted, so you should unmute yourself and let's do our thing. So the first question I think is probably for Ritesh. It's any recommendations on how to do right sizing and deal with high bursts?
Yeah. So I didn't mention it in the walkthrough, but one of the recommendations we do have is called a burstable recommendation. This is essentially a right size recommendation where we suggest you move to a burstable SKU. A burstable SKU is a special type of SKU that allows you to kind of build up credits and go beyond the stated capacity using your credits. And this is especially useful when you have spiky workloads. So for the most part, your average is kind of low, and then, suddenly you've got major spikes. So we, in our algorithms, we do take that into account. We check for spikes. We compare spikes with the average and give recommendations where, we would suggest you move from, for example, a D14 V2 to a B8 or something like that.
Okay, I'm going to follow that up with another technical question, and then I see another one that's going to be good for Priyanshi. So Ritesh, one more question for you. How about IOPS, IO operations? The question is, how about IOPS? Sometimes we need bigger machines just because of IOPS needed for the workload. Do you use that metric when doing these recommendations, IOPS at all?
Yes, we do. And so for the sake of simplicity of the presentation, I kind of just discussed CPU and memory, but we do take network IOPS into account as well. So the network IOPS has the same kind of targets that CPU has. And so we set the same, 40%, 80% based on user facing or non-user facing for network metrics as well. So if your workload is network bound, then we take that into account and make sure that your IOPS doesn't go beyond a certain level when we recommend a smaller SKU with lower IOPS capacity.
Okay, cool. I have a question that's not in the list that I see here, but I saw in chat for Priyanshi about reserved instances. So the question is everything available for reserved instances or only certain types? And is everything available for 3 years? Why 3 years? Why not like 2.5 years? Questions like that. Could you talk a little bit about that?
Absolutely. So a lot of services are available for reserved instances. Obviously, VMs are our biggest, I would say, portion of our reserved instances, but we have for SQL, Databricks, file storage, and there's a long list, which I don't even remember, but I'll post a link in the, I've all the links that are posted would have that information already. Then the other question, which is around, sorry, what was the other question?
Well, the other question is like, why 1 year, why 3 year,
Oh,
why
absolutely.
not 2.5 years? Like, like where do these come from? And is everything available for a 3-year one, for example?
So most of the products are available for 3 years and 1 year both. It's just that it's most optimized for 3 years, and also the discounts are higher for 3 years versus 1 year.
Okay, cool. That makes sense. Okay, more questions. This is a kind of an interesting one from Andre. Can advisories go the other way, like exceeding VM limits consistently or being under provisioned with services like Azure DocDB? Anybody want to take that one? I think it's the question is like, are there reverse recommendations?
Got it. That's I'm guessing what this means is, are there upsizing recommendations? Like if I'm, well, what I described is VMs being underutilized and us choosing us, recommending a smaller size. Do we detect consistently high usage, which will impact performance and give upsize recommendations? So right now that doesn't exist, but I'm happy to say that it is something we are actively working on, and it is going to show up at some point in the next maybe 6 months kind of time frame. And just to kind of note that that's not going to be a cost optimization, because you're going to a bigger SKU, it's going to cost more, but it is going to be a performance optimization recommendation where we make sure that where we identify VMs that are constantly hitting the limits, and we recommend something so that you're not getting those performance bottlenecks.
That makes sense. And I'm often reminded that cost optimization isn't always about saving money. It's about figuring out like what's the right value for your money. But I'm looking at the timer here, and I'm thinking that we are going to run out of time for me to ask you questions online. Would you folks have a few minutes to stick around and help us out with the chat and, bring your wisdom to that?
Yeah, I'm looking in the chat. I love the questions. I'm happy to kind of jump right in and answer them.
Well,
Same here.
Oh, awesome. Well, thank you, Ritesh and Priyanshi. I really appreciate that. I unfortunately have to move us on to the next pillar. We're moving at such a fast rate because this stuff is so great. So now it's time to talk about, well, let's see if we talked about it. We talked about what, the front door. We talked about security of it. We talked about cost. And now the question is around operational excellence. And it's going to be kind of exciting because we're going to get a chance to talk to someone about the very stuff, the mechanisms that are used every time, for example, you go to the portal and say, I want one of those. And to do that, I'd really like to bring on Alex, if I could. Alex, would you be willing to talk a little bit about operational excellence to these fine folks?
I would love to talk about operational excellence with these fine folks.
Have at it.
Cool. Thank you. So hi, everyone. My name's Alex Frankel. I'm a program manager on the Azure deployments team. And today we're going to talk about, we're calling it ARM Templates Unplugged, which is how your resources are actually deployed, whether you're going through the portal or through some other mechanisms for deploying resources. So I'm sure most of the people who are watching this are familiar in some way with the Azure portal, and they've seen this screen. What you may not know as you're working through the Azure portal and creating and updating resources in particular is that many of those operations are actually carried out by this thing that we call ARM templates. And this talk is going to walk you through how that actually works from end to end and what the ARM templates are actually doing behind the scenes. So most folks who start in Azure, this is how I started using Azure, they start by creating a virtual machine and they see a screen just like this. And they go through and they fill out all the forms and they see, maybe new concepts like subscriptions and resource groups and try to learn about all those different things. As you go through and you fill out all the details of this form, you'll eventually click on the Review and Create tab, or maybe you'll click on the Review and Create button down here. When you go to this screen, it's going to go through this validation procedure, and the validation procedure is going to check that all the values that you put in are valid. And to the best of our ability, we'll make sure that the virtual machine and the associated resources that you're going to deploy are actually going to succeed. At this point, you will actually click the create button, and you'll create your VM, and you'll log into it. You'll do whatever you need to do on that virtual machine, and all is good. But what you may not know, and what you may have never clicked on before, is this link to the right, which is download a template for automation. So this is on every review and create screen in Azure. Let's go and look what it actually says, or what it actually does. So on this screen, on the download a template blade, we see kind of a lot going on here. In the main part of the screen, we're seeing this JSON file, this JavaScript object notation file. That is actually an ARM template. This is just the top of the ARM template that describes some parameters, but there's a lot more underneath it that describe all the actual resources. You don't need to know a ton about, how an ARM template actually works or what the code actually means. But what's important to understand is that this is the actual ARM template that the Azure portal is going to use to create your resources. So if we actually explore the screen a little bit further, we'll see some things that hopefully we're familiar with from deploying virtual machines, even if we just understand deploying VMs from the perspective of the portal. We see, somewhat cryptic references to the network interface card and the network security group and the public IP address and the actual virtual machine. These are all the resources that are actually going to be deployed by the ARM template. We can see the icons of those resources. So there's a little bit of familiarity that we can start to build up. One thing that is really useful, and one thing that I do all the time in Azure, particularly when there are new resource types and new services that are being released, is I'll go through that create wizard and click that download a template link, this page that we're looking at, so I can get an understanding of how this resource is put together. And the template that we're looking at is actually hand authored by the service team. So it tends to be a pretty clean and pretty reliable ARM template if you want to take that and modify it and use it for yourself. Which is a little different from the export template capability, which you might be familiar with. That's actually machine-generated code, so it's a little messier. It can be useful, especially if you didn't go through this workflow and you need some ARM templates, but it's not as clean as what you see through this experience. So what actually happens when you click the create button? How do you go from an ARM template on the left-hand side to all these resources being provisioned, in this case, the 4 resources that were described in the ARM template? That's really what I'm going to get into for the rest of my time today. The first step in this process is you have to kick off the deployment. So either you click the create button in the portal, or you might be going through the Azure CLI, and you might be familiar with the AZ deployment create command, which allows you to send a template to Azure just like as if you did it in the portal. That then goes to the ARM deployments endpoint, or the deployments API. So just like there's an API for creating a virtual machine and there's an API for creating a storage account, there's actually an API for creating ARM template deployments. From there, the deployments API will hand off your template to what we sometimes call the deployments runtime. And the deployments runtime is responsible for evaluating your ARM template. So an ARM template is, a programming language. It can be dynamic, you can have conditions, you can have loops. It's the job of the deployments runtime to resolve all that before it hands it off to the actual resources to provision them. So as an example, this is a small little snippet from an ARM template where the name of the resource is dynamic. It's going to be a parameter. So when you actually deploy it, you're going to provide a value for it. It's the job of the deployments runtime to replace this expression that we're looking at here with the actual value of the parameter so that it can be then passed on. Once all those expressions have been evaluated fully, the deployments runtime is going to go and talk to all the resource providers all at the same time in parallel to make sure your resources deploy as fast as possible. If you've never heard of a resource provider before, it's essentially like a namespace. It's a way of keeping different sets of resources cleanly separated. So as an example, the common resource providers are like compute or storage or network, and then the associated resource types within those resource providers are things like virtual machine, storage account, or virtual network resources. Now, one thing that is particularly kind of mysterious in this workflow is exactly what is happening in this deployment's runtime. How does it actually work? What if something goes wrong in that process? I know when I started learning about ARM templates, this was really the mystery for me. And as I've learned more about it, and as we're going to talk about it today, it's really helped me understand how Azure works and helps me debug any issues with my ARM templates on a day-to-day basis. So what happens actually when you submit the template? So you've hit the create button. There's actually quite a bit that happens before we actually start deploying your resources in order to make sure that it's deploying successfully. So at the beginning, we start with this create, the submission of the template. And then after that, we do what we call syntax validation. So this is actually looking at the code of your ARM template, and it's making sure that the syntax itself is correct. It's valid JSON, it's valid ARM template language. In this case, we're looking at an expression in an ARM template. We're trying to get the location from the resource group that we're deploying to. It's missing a dot between the parentheses and location. That's kind of a standard syntax error. If you were editing this template using our tooling, using the ARM tools extension in VS Code, you would catch this there. But if you happen to miss it through there, when you actually go and submit the template, we'll catch it there and fail your deployment right away, so you don't get too far into your deployment before we identify something wrong. The next step is pre-flight validation. So pre-flight validation is a little more involved, and this is something that we can do special when you're deploying with an ARM template. Basically, what we're doing is taking the resource that you want to deploy and checking with the resource provider to make sure that a resource with these settings will actually successfully deploy. So as an example, and you'll see this when you create websites in Azure, and you'll see this in several other places, we're able to validate that, in this case, your website name is either available or unavailable. And if it's unavailable, we won't attempt to start the deployment because we know that resource is going to fail. And you can imagine maybe you're creating 20 different websites in an ARM template, or 3 different websites. And maybe the first 2 are not taken and they're valid, but the third one is. With pre-flight validation, we can actually check this up front so that we don't start the deployment and fail halfway through. And actually, if we go back to the screen that we were looking at before, that review and create tab, and you see that validation passed banner at the top, that's actually a result of running pre-flight validation on the ARM template. And one of the reasons that the portal relies on ARM templates to do all these deployments is because of things like pre-flight, where they can reduce their error rate because more things can be checked up front. So it's a really critical part of making sure that your resources deploy successfully. And then finally, once all of that is done, that's when we start deploying the resources. Now, there's one other piece of this that I do want to talk about, which is a capability that we call what if. And what if, the job of what if is essentially to predict your deployment. And what it does, and why it's particularly useful, is it does all the same things as submitting the template, that create workflow, except for deploying the resources. So it's a great way to do your syntax validation and your pre-flight validation, as well as get a prediction of what we think the deployment is actually going to do. And we do that by comparing what's in your ARM template with what is in Azure. And then we show you the difference. In this case, we're looking at deploying via the CLI, and we can see for this virtual network, there are certain properties like tags are being removed or the address prefixes are being changed. So this is a really good kind of muscle memory thing to do as you're authoring templates and wanting to validate them and make sure that they're deploying successfully. So now we're at the point of actually deploying resources. I bet you didn't know there was so much involved before the resources actually get deployed. I mentioned before that all the resources will be deployed in parallel, but in reality, there's usually a sequence of events that needs to take place because you can't create the virtual machine without the network interface card being deployed first. And you can't create the NIC unless the public IP address and the VNet are deployed before that. So what we do with the ARM template is we evaluate it and create what we call an execution graph, which is the order in which the resources are going to be deployed. And that's marked in the ARM template with a property called depends on, which I'll show you a bit in a second. What's convenient, and we're going back to a screen we saw earlier, is that the portal offers a way to visualize this execution graph. If we look at this button up at the top here, there's a way to visualize the template. And if we were to click on that, we would see this exact diagram. And this is showing me what the execution graph is going to be. It's a little confusing because it's actually deploying from the bottom up rather than the top down. So what's going to happen is we're going to deploy this bottom layer first, then we're going to deploy the NIC, and then we're going to deploy the VM. But for the sake of this presentation, let's review it in more of a top-down order where it's a little more comprehensible. So here's what happens when the actual resources are deployed. The first thing we're going to do is create the VNet and the public IP address at the same time, because when we look at the ARM template, there's no resources that these two are dependent on. So they can go in parallel and deploy really quickly. What happens when those resources are being deployed is basically we start the deployment of both of them, and then the deployments engine continuously checks until they're done. This is called a long-running operation, which is very common. Most resources take at least a few seconds to a few minutes to deploy, depending on what the resource is. And then only once those are done do we move on to the next step, which in this case is the network interface. Now, if I go and look at the network interface and I look at the ARM template and I look at the depends on property, I will see a reference to the virtual network and the public IP address. There's an expression here, once it gets fully evaluated, it ends up being the actual name of the VNet and the actual name of the public IP address. And so this is how the ARM template knows to wait for those first two resources before moving on to the next one. And then same thing, that network interface is going to create. And then once it's done, we'll move on to the virtual machine. And then if we looked at the template for this VM, we would see that there's a depends on statement depending on the network interface card. So this is how the actual sequence of events gets determined. So now all the resources have been successfully deployed. This was a successful deployment, thank goodness. If you go into Azure and you look for this deployment, you'll find it. In this case, under the resource group Blade, you'll see something that says deployments. Because the deployment itself is an actual resource in Azure, and you can query it and you can explore it just like you can explore any other resource in Azure. When you go and you look at this, you'll see this table with all the different resources that you deployed, as well as a status of whether it deployed successfully or not. I wanted to call out two important pieces of information here because you'll see this screen a lot in Azure. The first one is what's called the operation details. So for each resource that you deploy in a template, it'll have its own associated operation details. You can certainly look at it if it deploys successfully, but where it becomes particularly important is if the resource does not deploy successfully for whatever reason. So any errors that are omitted will be captured in these operation details, so you can go and explore that and do some more debugging. Sometimes the error that is provided by the resource provider is not as detailed as you want it to be or need it to be, and you may not know what the right solution is. If that happens, we emit what's called a correlation ID for all of your deployments in Azure. And what this does is it gives us an opportunity to look in our backend logs, which can be a little more detailed. So what you can do is you can use this information to open up a support case if you have Microsoft support plans per your Azure agreement, and you can send that to us, and we can usually do some pretty effective debugging and help you get an answer as we work with the resource provider team to make sure those errors are even more helpful for the next person. Now, the last thing I wanted to talk about is this project that we have going on called Bicep, which is a domain-specific language for making authoring ARM templates easier. So we looked at an ARM template. It was pretty verbose. It was pretty hard to read. We talked about things like depends on, which can be difficult to author and difficult to get right. There's a lot of those kind of error-prone elements of authoring ARM templates. So with Bicep, what we're doing is creating a language that sits directly on top of ARM templates and actually turns into ARM templates before they're deployed to Azure. But you don't need to work with the ARM template directly. You work with the Bicep language. And what that means is you get all the power of ARM templates, all the capabilities like what if and pre-flight and parallel deployments and all these sorts of things, but in a much easier to author language, which we're calling Bicep, which is a really cheesy dad joke. This is a little indication of what Bicep looks like. So this is a really small representation of Bicep code, but you can already see it's easier to read, easier to process, and much easier to author. We also do really great validation when you're authoring Bicep code. So it's a really good end-to-end experience. And now that you know how ARM templates work, a lot of what you're doing in Bicep will feel very familiar. So that's pretty much all I have for today. If you want to get started with ARM templates, if you want to do kind of just what we were walking through today and you want to author the actual JSON files, we have great documentation on how to author ARM templates, and there's links to great tooling for authoring ARM templates. If you want to use kind of the next generation of ARM templates, which is Bicep, we have a learning path for you to walk through end-to-end how Bicep works, and there's lots of tooling and lots of great information there for you to get started. So that's all I have. Thank you for having me today.
Cool. Well, I'm so glad you're here because we have a bunch of questions.
Cool.
And I think that the questions kind of divide up evenly between Bicep and ARM. Which
Cool.
do you want to take first? The ARM ones or the Bicep ones first?
You pick. You're the moderator.
Okay, fair enough. I can do that. Well, let's start on. I will go right to Bicep, right? Because
Cool.
I think the majority is there because people are apparently really fired up about it.
Great.
So I think you've done a good job of talking about like what Bicep is and where it comes from and stuff like that. But people are like, oh yeah, I get it. It's cool. When can I get a download a Bicep file there as well? Are there any plans to get a download a Bicep file in addition to download an ARM template?
Yeah, great question. So we do want to make it so that you can kind of fully abstract the ARM template away from your life if you never want to look at a pile of JSON again. So we will have the ability to, when you do download a template for automation, you'll be able to download Bicep code instead. When you export, you'll be able to export Bicep code instead. And then there is an ability to deploy custom ARM templates in the portal that we didn't show today, but we will also update that with the ability to upload or copy and paste Bicep code directly there so you can work with Bicep end to end.
Well, people seem to be really excited about it, so I'm glad this is coming. One other question that's related to that is, and I don't know if you actually have insight into this, what's the timeline for deployment stacks in Bicep, and how can we get in on the preview?
Wow,
So,
you have a very well-educated audience. They know the bleeding edge. So deployment stacks, which we didn't have an opportunity to get into today, is for helping you manage the life cycle of the resources. So it's all well and good that we stood up this VM and the 3 resources that are associated with it. But what happens when you want to turn around and clean everything up? Especially if those resources are spread across resource groups, which in like networking scenarios, it's very common to have resources spread across resource groups or even spread across subscriptions. The deployment stack essentially keeps track of all of those resources that are in the template or in the Bicep code and gives you a really easy way to clean it all up in a single gesture. So fingers crossed, we're hoping that the private preview for deployment stacks starts in the next 2 to 3 weeks. And you can sign up for the private preview at the AKA link, aka.ms/get stacks, GET stacks.
Cool. Okay. So I think there's other questions. There's other questions about Bicep that we've talked about, like what your take is on ARM versus Bicep. I think we have some sense of you dig it, like both of them. I think would be a safe thing to say. Do you want to say anything about people about what, if they're going to go start with something, should they start with ARM or should they start, Azure Resource Manager templates, or should they start with Bicep?
I think it's safe at this point to start with Bicep. So Bicep is, we sometimes call it transparent abstraction, and that just means all of ARM is exposed to you through Bicep, just in kind of a nicer interface. So you're still going to learn the details of how ARM works and even how ARM templates works, but you're going to get better validation. You're going to get code that's easier to read and all these sorts of benefits. So I would start with Bicep, but you are going to see in your day-to-day of Azure, depending on what you interface with, you will see ARM JSON, not necessarily an ARM template, but if you do a GET request on an Azure resource, you're going to see the JSON returned. So it's still good to get familiar with where you'll encounter JSON and what that looks like. But for your day-to-day authoring, I would start with Bicep.
Cool. Okay, so let me ask a question that connects right to that. Somebody said, when we invoke a REST API to create a storage account, is that invoking an ARM template on the platform side as well?
Great question. So that is actually circumventing ARM templates. And so the negative of doing that is that you avoid all of those pre-flight checks that we do before the template is kicked off. So especially if you're coordinating a lot of different resources together, it's better to do that with an ARM template than with individual API calls, because we can evaluate the whole ARM template in its entirety and say, okay, this person isn't creating one storage account, they're creating 100. Let's make sure they have the right quota for that much storage in their subscription and so on. So that's some of the trade-off that you make by using ARM templates versus using something else.
Cool. Well, there are a ton of questions in the chat. If you would be so kind to drop in and maybe help answer some of that, that would be really appreciated. Obviously, this is a subject people care deeply about, and I really appreciate you coming to talk to us about it today.
Yeah, you bet. Thanks for having me, and I'll definitely answer some more questions. Awesome.
Well, thank you very much. So now the question is, we've talked about all these things, and we're at our last pillar. And the question I would want to, the question is like, how do we top all the things that we've talked about? And to do that, we're going to go into the land of performance efficiency. And for that, I'd like to bring on a recording, because it was, again, a little hard to get everybody scheduled into the right place, from Sophia, who's going to talk about performance efficiency. And then the good news is that we're going to get a chance to talk to her and ask her some questions right after this. So let's go back to the studio where we're having a chance to talk to Sophia.
Hey everyone, I'm Sophia Joyson, and I work in the Azure Core Fundamentals team. Today, we're going to be talking about how to optimize for quick and reliable virtual machine deployments. We know that when someone wants a virtual machine from Azure, they want it fast. Whether you're pushing a button on Portal or sending an API call, the desired outcome is the same. I'm going to show you how virtual machine provisioning happens, and then take you behind the scenes on some internal platform capabilities that can speed up your experience. Creating a virtual machine pretty much never means just a virtual machine by its lonesome. As we saw in Alex's presentation on ARM templates, creating a virtual machine includes the creation or use of many additional resources, some required and some only needing depending on your workload and goals. You have the network interface, or the NIC, and this is the interconnection between the virtual machine and the virtual network. Then you have the network security group along with the subnet, and that subnet is part of a VNet. And if you want more data, you can have associated data disks. And if you need to get information about your VM during provisioning, you can have your diagnostics logs and screenshots stored in a storage account. Lastly, of course, you have an IP in order to interact with a VM. On top of the additional resources, there are choices that you're going to have to make for the virtual machine itself. The size and the type of the virtual machine, the operating system, the image, so the distribution and the version, and then the availability options. There are so many selections to choose from in order to fit your workload needs. I'm going to share how you can optimize for performance and reliability. When you think about conventional resource provisioning, everything happens on demand. So as a customer, you might log into the Azure portal to create a virtual machine that you want. When that request comes in, the virtual machine and all the associated resources, which we saw on the previous slide, are created at runtime. So we build the machine up and then we run it through provisioning, which you can akin to as if you were installing Windows on your laptop for the very first time. This process is all about building the resources together at the time of the request. The virtual machine itself, the NICs, the storage accounts. Over time, we've made optimizations to create these resources faster. And that is the journey that we're going to dive into so that you can learn how to leverage them. The first optimization I want to talk about is prefetch. When Azure was beginning, we made the decision to put the OS disk on remote storage. That way, if there were any issues on the host node, we could spin up a VM on a new node and the user wouldn't be impacted by any loss of data. This additional reliability was a trade-off with performance. Of all the steps that occur in conventional resource provisioning, there's one specific step that takes the longest, and that is what we're going to optimize here. The goal of prefetch is to reduce the latency that is incurred between the node and storage by bringing down the OS contents to the host node before they're needed. Because we can't bring everything, we try to determine what is needed as accurately as possible. When a new image gets published to the image repositories in Azure, prefetch service is invoked in the background. Now, what prefetch service will actually do is bring up a sample virtual machine with that image and look at the OS disk activity that's occurring during the boot and provisioning phases. This metadata is captured and then put back on the OS disk, which we call prefetch metadata stamping. When a VM is booting on the host node, it will check for that prefetch metadata and read it. So tip number 1 here, if you're building your own image, ensure that the first megabyte of the OS disk is empty so that we can stamp the prefetch metadata. This will ensure that your image is prefetchable and will yield significant latency gains. If you're building your image from an approved base, you don't need to worry about this part. Another optimization is managed boot diagnostics. Boot diagnostics is a feature for virtual machines that allows for the diagnosis of VM boot failures. This feature enables you to observe the state of the virtual machine as it's booting by collecting log information and screenshots. And in order to have that, you need to have a storage option for this data to be retained in. Previously, you only had the choice to either leverage a user-managed storage account or disable the feature. For the user-managed storage account, if you didn't have one already, you would need to create one, meaning another resource being created at runtime along with the virtual machine. With the new managed account option, you can get the diagnostics without needing to manage or even create a storage account. These storage accounts are pre-created ahead of time, resulting in minimal latency, and Azure is owning the accounts, making the management easier on you. So tip number 2 here is to leverage managed storage accounts for virtual machines if you can. This will reduce your VM provisioning latency and management overhead. The next platform capability I want to share with you all is something called pre-provisioned virtual machines. This platform capability seeks to remove as much of the resource creation at runtime as possible. There are 3 high-level steps to pre-provisioned virtual machines. The first is prediction, where we analyze the virtual machine deployments across Azure and predict what will be needed in the future using AI capabilities. That prediction is then leveraged to prepare virtual machines in advance of a request coming in, and these VMs are kept in what we call a partially provisioned state. The last step I like to call activation, where final configurations specific to a customer request are applied and the virtual machines are handed off in a fully provisioned state. So what does this mean for you all as a customer? First thing is significantly lower latency experienced in virtual machine deployment. The need to fully provision a virtual machine at the time of a request coming in is removed, and this obviously has a benefit to the latency that's experienced. The other is reliability, as VMs in this pathway are already up and running. Let's dive into each phase in a bit more detail. Millions of virtual machines are deployed every day in Azure. Our algorithm looks at a history of all the virtual machine deployments and predicts what virtual machines will be needed in the future for customers. As we went over in the beginning, there are a lot of different specifications for customers to select for virtual machines. All these properties can really be bubbled up into two categories from a pre-provisioned virtual machine perspective: things that are immutable and things that are not. So what makes something immutable? The answer is if it needs a reboot. I can't make a Linux machine into a Windows machine, so I'm going to have to predict for the operating system. I also can't take a Debian image and make it the latest Databricks image, so I'll need to predict for the image. On the other hand, I can change the username or the machine name. This is the principle that guides us for what we need to predict for versus what we can handle on the fly. Believe it or not, the number of possible virtual machine configurations comes close to 70,000. Now, I want to make a quick note on our algorithm. Our very talented data scientists created a new framework in order to best approach this problem. The prediction component predicts for future demands and models prediction uncertainty, and the optimization component conducts probabilistic optimization, factoring in the most beneficial customer experience. It then goes through a period of training and maximizes the solution quality and finalizes the pre-provisioning plan. Of course, this is a very simplified description. If you're interested in learning more, we have some scholarly articles linked on the last content slide from the team. The last step of the prediction phase is to hand off the top N VM configurations and the suggested count of each. This next step here is the actual pre-provisioning. So once the prediction is received, it will go through another level of platform filtering in order to scope to the maximum number of predictions, balance with capacity needs, and so on. From a platform perspective, it actually seems like we're creating a VM just as usual. The only difference here is that it's tagged to denote a special functionality. Inside the guest is where it understands that this is a pre-provisioned virtual machine and not a regular one. It'll go into a mode where it's waiting for those customer-specific settings to be supplied, which basically means we have an agent running inside the guest that's doing all the magic. From a security perspective, I want to call out that these VMs have no public IP and no internet connectivity. This means that no one can connect to them, and they're secured in this dormant state. The last step is activation. So when a request comes into Azure with the virtual machine configuration matching one that has been pre-created, we can give that virtual machine to the customer. The agents are taken out of a waiting mode by getting supplied the information that they're looking for, and the process for finishing up provisioning and handing off the virtual machine to a customer can begin. A transfer of resources occurs, and we relinquish any control over the virtual machine, and it's owned fully by the customer. While there's, of course, some really cool technical, innovative details that happens here, I have to keep some ingredients to the secret sauce secret. The big question that's probably left on your mind at the end of this is really great stuff, so how do I leverage it? Because pre-provisioned machines is an internal platform capability, customers don't directly interact with it. And as I said, there are 70,000 possible configurations. So how do you optimize for being predicted? Let's shift over to some tips for that. In general, the term latest is greatest is a good rule of thumb to follow for maximizing your deployments with pre-provisioned virtual machine capabilities. This is true whether you're thinking about images, a feature offering, VM sizes, etc. Now, let's take a quick focus on images. Using the most recent images from Linux or Windows will ensure that you have support at the image level. When specifying the version of the image, going with the latest will provide an additional boost to predictability. And this last point, which is super key, leveraging Azure's platform image repository or shared image gallery for your images to ensure accessibility to them. The next thing I want to talk about is virtual machine sizes and types. Now, whether you're optimizing for CPU, storage, or memory, every virtual machine family has either premium or standard options. These terminologies more or less map to the existence of an S in the name. A simple example would be the general purpose D family VMs. There's the DV4 series, which is considered standard, and the DSV4 series, which is considered premium. For better performance, opt for the premium virtual machine SKUs. Now, another note I want to make on virtual machines is making sure that you have the right size. The storage throughput, or maximum IOPS, will depend on the virtual machine size and the size of the disk. Put it this way, if we were in a shoe store and you were in between sizes, my recommendation would be to size up. This would reduce the potential for IOPS throttling during virtual machine provisioning. Of course, this is a balance with cost as well. The same philosophy can be applied for premium versus standard storage. My recommendation is to opt for premium storage if you can, for better performance and reliability. The last thing I want to talk about are the several availability offerings for virtual machines. Opting for the newest ones if you can, of availability zones, or the super recently public previewed virtual machine scale sets with flexible orchestration will improve the provisioning experience and prediction. For the newly announced virtual machine scale sets with flexible orchestration, I can't even begin to list out the benefits to customers. Fast scalability, ease of use, high availability, customizable, and so much more. And the combination of this and pre-provisioned virtual machines is, well, fast and furious. Thank you so much for having me here today. Here are some resources that I've linked that relate to the talk. Now let's go back to live for some Q&A.
And here we are live. So I'm excited because I think we have Sophia available to actually answer a few questions in our remaining time in this thing. Hey, Sophia.
Hey, everyone.
Wow, just judging by the number of questions we've got, like this is a really awesome session. So can I ask you some of the things we've got here on
Yeah,
deck?
for sure.
Okay, so here's I think a really interesting one. What if my deployment does not get a pre-provisioned virtual machine? What happens?
Yeah, that's a great question. So if your deployment doesn't get a pre-provisioned virtual machine, it will go through that conventional provisioning cycle that I talked about in the beginning of the presentation. So we'll basically build up the resources for the machine from scratch and then run it through provisioning. So it'll go through a non-pre-provisioned pathway and go through that conventional phase.
Okay, cool. Another question we have from Arvid is, I'm assuming pre-provisioned virtual machines provide more benefits for auto-scaling scenarios. Are there any benefit examples? I'm not sure what they mean by any benefit examples, but auto-scaling comes into play here as well, right?
Yeah, so I mean, there's other examples aside from auto-scaling. So when you have maybe a regular schedule of deployments that are consistent and you're just having jobs that are running, constantly, then, you can have that capability for that as well. It's not just for auto-scaling. For anything that, has regular deployment schedules, pre-provisioned virtual machines could be used for that. So again, I guess the one thing is like a consistency of deployments obviously helps when you're looking at, prediction, but it doesn't just have to be for auto-scaling.
Okay, so I'm going to combine one of the questions with one of my own. What this person asks, Arvin asks, I'm assuming that what's being presented at the moment is more in ensuring fast provisioning of compute resources. Is that a close assumption? Which I think that's right? It's about fast provisioning of resources.
Yes, fast provisioning of resources. But it's not only compute like I talked about in the beginning. So when you have a virtual machine, it's not only a virtual machine, right? There's also the associated networking resources that come with it. And so it's not just about the compute resources, it's about the request of the virtual machine itself, which could include any of those associated resources. But of course, when we're talking about virtual machines, we're generally in the compute land area.
Right. Well, so that makes sense to me. But so that leads to my question, which is, what can I do to make it more likely that I'm going to get, something that's going to come out that's going to come out fast? What knobs can I turn?
Yeah, I mean, like I said, there are so many different, possible configurations of virtual machines, close to 70,000, which is really insane. And the tips on the last slide are really what I would recommend the best way to get predicted for. You're trying to maybe, I guess, a better way to say it is be in the most common scenarios if you can, but if you're deploying at such a high volume, you're also in that area as well. So I would say the tips on the last slide are probably the best thing I can say to get predicted for. But of course, if you have further questions, I'd be happy to sync with you all offline and answer those as well.
Cool, I appreciate that. Well, one of the things that I noticed that you had on that slide was you had mentioned, especially for things around prefetch, like leaving some space available at the beginning of your disk images.
Yeah.
Can we tell people how to do that? Is that an easy thing to do?
We do tell people how to do it. So in the last content slide, I have a link at the top, and the first one is about prefetch. And if you scroll down on that link, you'll actually see that it talks about how to do that for an empty VHD as well as a VHD that has content in it. So if you click that link, you should figure out how to make sure that your first megabyte of space on the disk is empty.
Awesome. Last question, because we got to move on, and I actually have to close this thing up. Believe it or not, I want to talk about this all day. Will pre-provisioning also help in reducing the time further for scale sets?
Yes, it does as well. It does indeed.
Okay, I like yes answers. Well, thank you so much, Sophia, for helping out. If you have a couple of seconds, I know that the chat's going to go away at the end of this broadcast, but if you have a chance to answer some of the billions of questions we're getting, I would really appreciate that. But I think it's probably my time to thank you and thank all the other speakers and just close up the store. So I would like to take a moment to thank all of the speakers and all of the organizers for this sort of event. I thought it was pretty amazing. We'd love to know what you think. There'll be a survey for you to answer. You can always feel free to tweet directly to me at OtterBook if you want to give me stuff, information. Did you like the format? Did you like the content? Should we do more of these? Is this something that you're really into? I also want to make sure to thank Mark Rasinovich, who is willing to help open this sort of thing. And I want to thank especially all of you who are interested in going backstage at Azure. It was really great. I'd encourage you to check out the Well-Architected Framework docs we have, because we really want you to thrive on Azure and enjoy. So thank you, everybody. This has been amazing. I really appreciate you joining us. Take good care. Oh, and one other thing I want to mention before I forget, I'd also like to mention that if you are interested in hearing this content, if English is not your native language, and thank you for joining us, even if it's not, we'll be holding this sort of thing around the world in 5 other different languages, thanks to our Reactor community. Look for more information about that on this link right here, the upcoming WAF events. So I have a couple of closing slides I need to mention, if you would be so kind as to bring them up, just so you have that available. Whoop, there we go. The thing I want to mention is if you like this sort of stuff and you want to know what else is coming up on LearnTV, we have some great stuff here. Like if you've never been to LearnTV, welcome for the first time, but I encourage you to come check that out. So thank you very much for everybody. And we hope to see you later. Oh, yeah, and here's some stuff if you'd like to see this on demand and you'd like to check out Microsoft Learn. So with that, I'm going to say goodbye to you. Thank you all for attending. Thank you for coming backstage. We look forward to seeing you some other time soon.